Welcome to the third video in the sixth video module, the Obby Electronics Case Study 3 Implementation Module. And this video picks up where the previous video left off. So this is not one where you want to jump in here on video 3 without watching video 2. In video 2, we started our implementation and we defined our resources table and used auto create for our object instances. We then defined our materials, and our materials are divided into the finished goods and the raw materials. We defined the routings by material using the routing table and specified the destination, the sequence destination, and the processing times for each of the three phases of our task sequence. And then we defined three orders, or we defined our initial order table and three orders that we use to do a little bit of brief model verification. So we went in and showed how the sequences were correct, the transfer nodes select from list was correct, and so on. And so in this video, we're ready to move on, and we have two more major components to add to our model. The first one is sequence-dependent setups. So if you remember back from the assignment, we have three different modules, and the modules can be one of four different colors. And in addition to the normal setup operation here at finish, where we have a 10-minute setup between orders, we also have a sequence-dependent setup where if you're changing from one color module to another, you incur the sequence-dependent setup. And so the first thing that we're going to do is look at how to do that sequence-dependent setup implementation. So let me go back to Simio model here just a second. And so our starting point that we're going to do is we're going to go look at data, and we're going to go over here to changeover matrices. And if you've never seen this, it might be beneficial for you to go look at the help. There's also a couple of sim bits that do these and so on. So you could stop the video and go look at those or you can watch for a while, and if there's any cause for confusion, then you can always pause the video and go look at those. Okay, so here we are in changeover matrices, and I'm just going to add one, and you can see we have changeover matrix here. I'll just change the name so we know which this is. This is finish changeover, and you can see that one of the things that we have to specify is something called the string list name. And the way Simio changeover matrices work is you have a string list which defines the from and to components of the matrix. So we're going to go in and create one. We're going to go in and create a string list. So go over to list here, and I want to create a string list, and we'll call this module colors. And our available module colors in string form are red, green, if I can type here, blue, yellow. So we've created a list, a string list with these four elements. And so now if we go back to our changeover matrix, we can then say, okay, now we have a string list, and our string list is called module colors. And as soon as I do that, it creates my from to matrix with our four strings. So I'm going to change this to minutes because our units are specified as minutes in the assignment. So now what we need to do is go in and fill in this matrix with these from to values. Okay, so let me pull that up, do that here real quick. Okay, let's put the values in. So 240 to go from red to green, 240 to go from red to blue, 300 to go from red to yellow. Green to red is 120. Green to blue is 75. And green to yellow is 120. Blue to red is 75. Blue to green is 180. And blue to yellow is 120. And finally, from yellow to red is 150. From yellow to green is 75. And from yellow to blue is 120. So now we have our changeover matrix defined. The next thing that we're going to do is we're going to go back to definitions, elements, and define something called a changeover logic element. So we're going to just choose that, and we'll just leave the default name of changeover logic 1 for now. And you can see that we have something called setup transitions. And so this is a repeat group that lets us define multiple different setup transitions if we so choose. For our model, we only have one. the sequence dependent setup, because the other setup was handled in our task sequence as just a normal specific time task. So let's go add, and we have three attributes here. I'll come back to the attribute. The first one is changeover matrix true, and then so we can choose the changeover matrix. And so what the element needs to know now is, well, what's the operational attribute that I use to specify color? So it needs to know what color, how to interpret the color of the current entity. So if we go back, this is where in orders, we're going to add a color attribute. So I'm going to go back to my order table. We left that off earlier. And then I'm going to add a property. If I choose the property, what I need is to use a list element. A list property, so that I can use that module color list. So I'm going to go and choose list right here, right there, choose list. And then I'm just going to move it over here to right after the material name. I don't know why I moved it over there, just so it looks better, I guess. And so I choose my list, and you can see there are node lists that we defined earlier. And here's our module color list. And so now we have specified that type, and we can go in and then pick one of the colors. So let's just pick blue, blue, blue. Let's just say that all three orders are blue. And let's name this module color. Module color. So now we have a column, orders.module color, that specifies for any given order what its color is. So we can then go back to definitions and say, open up our changeover logic element, and now we say this is orders module color. So now when an entity arrives, it's going to have that row reference like it always does to the orders table, and then we now know what the attribute, what the color is for that entity. And then the changeover logic will then, in the task sequence, will then use the current color and the color that you're changing to in combination with that changeover matrix to implement the changeover. Back to our facility view. So now we have our three finished stations in the finished work center. And don't forget, we have our changeover operator. So when we have one of these sequence dependent changeovers, we need the operator to do the actual changeover. So I'm going to go to finish one, and we'll just open up the task sequences, the task sequence. And what we want to do is right after setup, add another task that happens before the process that implements that sequence dependent changeover. Now, luckily, we use this default numbering 10 and 20 and so on. So that gives us opportunity to insert tasks into the sequence. And so that's just what I'm going to do. I'm going to create a task. I'm going to number it 15 so that it comes right after 10 and before 20. And I'll name this one changeover to differentiate it from setup. And the type here now is sequence dependent setup. So we've already defined that sequence dependent setup. And so we just have to specify that logic element, which we just defined, and we left it at the default name of changeover logic 1. So this is going to implement. I can move this up here so it just looks right. You don't have to move it up because it's going to do them in order specified by the sequence number, but it's just a little bit easier to interpret if you have them in the by sequence number. And so the last thing I want to do here is I want to specify the resource requirement. So I can go back in here in the resource requirements for this task, and there's my specific one. And so now I'm going to say I need the changeover operator to do this task. So now we have the new task in our task sequence, and we have defined that for the finish station 1. So we have two options here now. We have to implement that same logic in finish 2 and finish 3. So we could do that. I could go in finish 2 and update that logic, and I could go in finish 3 and update that logic. What I'm going to do instead is I'm going to create a new object instance. So I'm going to go back and just right click here and say I want to create object from this. And instead of my AE server, we're going to name this, let's see here. See if I can see that, get rid of that. I'm going to name it AE finish server. And so AE finish server is now a new server which has been subclassed from our existing AE server. So it's going to inherit all of the properties from AE server, but it is a new object instance, or I'm sorry, object type. And so I can go back now in my data table where I define my resources, and there's my AE finish server. Let me just make this a little bit bigger. There's AE finish server that I just created, and then I can go back in and have AE finish server for finish 1 and finish 2. Go back to our model and have a quick look. And we have 4 rows, exactly what we expected. And if we pull up this task 15, it's sequence dependent setup, and it has the changeover operator. So at this point, I think we have our changeovers appropriately defined. And so the question is, how do we test these, right? So I'd like to, I think I have this right, but obviously what I'd like to be able to do is test it. Well, one way that we could do it, and the way that we're going to do it, is I'm going to go in the orders table, and right now you can see that I have 3 blue modules. And so if the timing is right, and I'm just guessing here, each one of these is going to go to one of the 3 finish servers. So I'll just create an order 4 and make it a different color. Order 4, and we'll make it, I don't know, module B, and we'll make this one red. And let's say we have 5 of these. And so now if order 1 goes to finish station 1, order 2 to finish station 2, and order 3 to finish station 3, then when order 4 comes along, it's going to go to one of those 3, and you're going to change over from blue to red. So let's go have a look. So let's go back to my resource plan. And we also have, oh, did I change over? Let's go back and look, make sure I did changeover operator. Yeah, log resources, true. And so now when we execute our plan, you can see here's our changeover operator right here, 35. And that looks like that happened. Let's see, where did that happen? For order 35, which happened on finish station 1. So it processed order 33 and then order 35. So one other thing I'm going to fix that's going to help us with debugging is I have this order.33, and that's just the default Simio name for that realization. So I'm going to go back to my order, and just like we did for dynamic label text, if I open the advanced option, I can use that same thing for display name. So we do orders, order ID. And so now when I go back to my Gantt chart and I regenerate, it's now using those names. And so I can easily look at this and say, hey, when I want to go from finish 1 from order 2 to order 4, then I'm going from order 2, which is blue, to order 4, which is red. And so if I look at my changeover matrix from blue to red, I should have a 75-minute delay. So this delay right here should be 75 minutes, which it is, 1 hour and 15 minutes. I can also go back in and add another one just to be comfortable with this. Let's just go back in and add one more order. So go back into my data table and let's add order 5, order 005. We'll make this, I don't know, module C. Let's make this one yellow, and we'll do 8 of these. And so now when I go back and plan, we now have that new order, and we should possibly have another changeover. So if we look at our changeover operator, you can see there's the previous one that we had with order 5. Now we have one with order 4 also. And so that happens, let's see, order 4 is at finish 2. Let me pop that guy open, and so there's our sequence-dependent changeover. So we have these sequence-dependent changeovers that occur only when you change colors. And now if we want to test that, let's just go back and make these all the same color. So if we make these all blue, then we will see the same allocation to workstations, but we shouldn't see any of these. So we should still see everything happen the same, all of the orders assigned to the same stations, but we shouldn't see these changeovers because everything is blue. So create the plan, and that's again, in fact, what we see is we look at our changeover operator, and the changeover operator is not used anywhere. And so we're pretty comfortable. If I was really doing this model, I would go in and do some additional testing, add some more orders. I'm going to leave that out of the video, but you should definitely do that before we come back and add the bill of materials, which is the last thing that we're going to do in this video. All right, so we're back. And as I said, the last thing that we want to do in this video is implement the bill of materials. So recall we have a single materials table that defines our finished goods and all of the constituent raw materials. And if we look back at our assignment, you can see here's where all of those bill of material components are defined. So module A requires component A, 2 component Bs, 4 component Cs in the kit area, a paint, which will be determined by the paint color, and then a box in the package area. And we said that we were going to implement those, and if we looked at our table structure, that we're going to implement those by connecting to the routing. So by connecting to the routing, we could specify those components in the bill of the material that correspond to kitting, those that correspond to finish, and those that correspond to packaging, all in the same table called bill of materials. So what I'm going to do is I'm going to go back into my model and define my bill of materials table. Let me pop open the model here. So here's the model. And so I'm going to create a new table, and I'm going to call this table bill of materials. Bill of materials. And the first component that I have is going to be a foreign key to my routing table so that I can connect up to the right component in the route. So we're going to go up to say foreign key property. This is going to be routing key, and then the default value here is my routing key. The second thing that I need is the component material, right? So we have the bill of materials defined. We have a materials table, but note this can't be a foreign key because I'm going to use the table column in my task sequence so that I can consume the correct material. And so back in our design, remember that that's why we have this second dotted line, just like we did here with the routing between the node, we have that dash line here, and that's saying, hey, okay, this is a material that's in this table, but it's not a foreign key. This is going to be an actual material element column, and that's why we have the dash line there. So let's add that. So I'm going to go back into my object property. That is going to be a material, and we're going to call this component material. And one quick thing here, when I pull this up, because it's defined as a material, we see all of the materials that we have defined, but again, those aren't directly tied to this table. Instead, those are defined to all of these materials, or constrained to all of these materials that are existing. So if you have other materials that you've defined that are not generated by that materials table, they'll show up. If not, then you're going to be constrained as you would expect to be to those materials that are in the table. And the last thing I need is the component quantity. So I'm going to take an integer value and call this QTY. And there we go. And so the next step, we need to fill the table in. And as before, I'm just going to paste it in from Excel. When I did this initially, I entered these all manually to go back and do testing. I'm not going to make you sit through that. So let me just grab these guys and then we'll talk through it. So just grab those, escape, paste. And note we have a couple of errors down here because I've specified in my Excel, I had the component material for paint specified using the orders.paint column, which of course we haven't yet defined. So I knew I was going to define it because I knew I had to have some way to reference the color, but I haven't yet done that. And so we now see those three errors because orders.paint doesn't exist. Now, the reason that these can be specific components, but these can't, is because when we look at the materials, for example, if I look at module A, if I look at module A in kitting, we know that it's component A, 2 component Bs, 4 component Cs. We know that all the time. But for finish, we don't know what color it is for every entity that comes through. We need to reference back to the color. So we have the material defined in the order, and the last thing we need to define in the order is the color. Now, if we go back, this is a little unusual and can be a little bit confusing. Let me go back to my orders table. We have something called the module color here where we've defined that, but the module color, remember, is what we use to identify the color for the transition matrix, the changeover matrix. So we need another entry here that specifies the material, right? So I need another material column here. So I'm going to just go in and add a material column. Let's see, where is material? Oh, it's element here. An element material. So my material column, and I'm going to name this paint. So we'll just go back here and name this paint. And then I will go and let's move this guy to the left so we have module color. And so now I need to choose my paint color. So I'm choosing paint not from the list, but from the list of materials. So there's blue, blue, paint blue, paint blue. Let's see here. And paint blue, we had these all blue before, so let's see, put those all in there. And now our errors disappear because when we go back to our bill of materials, now you can see, hey, we do now have that column orders.paint. Okay, so we've defined the bill of materials table. And if I look at any material again, let's go look at module C. The components in kitting are two component A's, two component B's, two component D's. The components in finish is the paint, and the component in packaging right here is box C. So that implements, or that defines, the complete set of bill of materials that we have defined in right here. So we define all three of these by linking them to the routing table. So if we're satisfied that we have the bill of materials defined, we now need to go back and say, okay, well, let's consume the bill of materials in the right place. And so we specified in the assignment that the bill of materials consumption happens in the setup task. So we can go to one of our AE servers. So let's just do kit, and we can go back up into and open the sequence. And what we need to do is now say, in this task, I want to have a material requirement. So the first thing that we're going to do is go back, and when we have to extend the processing task, and we have to define the table that we're going to use right here. So here's task materials reference table name. So we can just pick the bill of materials table, just like that. And then I can go back in and say, into my tasks, and say, here's what I need. So for my setup task, my material requirements, I want to consume bill of materials, component material. Bill of materials, component material, and then for required quantity, bill of materials, QTY. So now we have the links back to our bill of materials table, and so we can specify what those quantities are. Okay, so one quick thing that I need to fix here. So the component material is right, but the quantity's not, because the quantity needs to be, you need to take into consideration the order quantity. So what this does is says for each module, for example, for module A, I need 4 component C's, but if I have an order for 10 of those, I need 40. So we need to take this quantity and multiply it by orders, QTY. And I probably eventually would have figured that out, but let's go ahead and fix that here. So we fix that there, and then I can go back in and update properties from this. So we'll just go pick a symbol 2 here and make sure that those properties are set up correctly, and they are. So there's the component material, and there's the quantity, and if I expand that, there's the bill of materials. Now I need to go look and finish, because we had changed the task sequences. We need to go make sure that those were updated, and in fact they weren't. So you can see that I don't have the task material reference table here, so I need to put that in, bill of materials for the table, and then I'll pull up the processing tasks and go to sequence, and then look at material requirements, and if it's not there either, so I need to add that. Oops, I spelled it wrong. Let's just use let's see, bill of materials, if I can use this here. Bill of materials, component material. Use the expression editor, it's a little helpful. And then we need the required quantity, bill of materials, QTY times orders, QTY, do I have 3 L's here? Trying to do this over my shoulder, there we go. So now we have the bill of materials, component material, bill of materials quantity times order quantity, and then we can then just go and update my AE finish server. So we'll go check finish 2 just to make sure, and its table was not. So here's the problem you see sometimes when you update and you've changed individual tasks is you have to go in and make some of these modifications manually. So we just do bill of materials, and I think this one might be updated for me. Yeah, that's right. So the task sequence itself was updated. What wasn't updated was the table name. Bill of materials, and then we'll just go check its task sequence, and it is, yeah, it did inherit that. So once again, when we use a bill of materials from a table, don't forget there's two steps. The first step is to define the table in the task materials reference table name, and then to add the specific details in the corresponding task. In particular, you need the material name and the material quantity. So now we have our AE servers and our AE finish servers and our bill of material set up, and we think we have it set up correctly. But of course, we do need to do some testing here. So the very first thing I'm going to do is a really simple test, because if we know that all three modules require component A. So what if I don't have any component A's? So I start out with 0 quantity component A's. Entities should arrive here as normal, and when they get to kitting, they should get to that operation 10, and there should be no component A. So we'll just run it for a little while. Let me speed it up and make sure that we exceed the time. I don't remember what it was, somewhere around 2 hours or something like that. So we'll just let it run for a while, and you can see it doesn't appear to be going anywhere. And so, at this point, again, I'd stop it here, and then I can go back, and, we might want to try to do a plan. If I just create the plan, okay, you can see nothing happens. We have a kitting here that's constrained. So here's order 1 that's constrained at kitting. If I go expand that and expand the task, here we are. My task is constrained by component availability. So you can see component A, availability is constrained. So now you can see hopefully why we have this assume infinite availability, because we set the value to 0. We saw that it did block, and now we can go back in and say, well, what if we assume infinite availability? And then we go back in and execute. So run and fast forward, and now we see things, entities moving through. So if we go to our plan now and execute our plan, sure enough, we see orders that are being processed exactly as we expect. And then somewhere down here, things look like they back up again. That's what that hatch means. So if we just, again, look at the tasks, we can see, there's order 5. Order 5 is constrained by component D. So if we go back to our inventory here, we only had 25 component Ds. So what if we assume infinite availability there and then execute our plan again? So create our plan. Now everything is processed as we expect. So by having this little flag here that lets us assume infinite, it really helps us with debugging the system. Okay, so let's look at one other issue that comes up that we want to make sure that we prevent, and that is blocking at a bill of materials when you have entities that could be processed. So here's what we're going to do to demonstrate that. I'm going to go back to my data. I'm going to turn off infinite availability for D, and I'm going to say that we have no component Ds. So now anything that requires component D, which is only module C, by the way, is blocked. But since we have assume infinite availability on A, everything else should have plenty of inventory. So we'll go in and make all the components assume infinite except for D. And so then I'm going to go back to my orders table, and I'm going to make this first order for component C. And so that's going to block, and then make this one for component A, and this one for component B. So now we have one module C, an A, B, B, B. And so this one is going to happen first because they all arrive at time 0. So it's going to go sequentially. And so now when we execute, we can see here's order 1, right? And if I stop it, so if I pause the model and zoom in, let's just have a quick look at kit here. So just jump open the watch and zoom that up and go to kit, and what we want to look at is the routing out queue, and there it is. So here's order 2, order 3, order 4, and order 5 are all blocked here because order 1 doesn't have its required materials, but it's already moved into the kit station. So we want to prevent that from happening. What we want is that decision to be made right here and not let the entity block the station. And so we do that by using a constraint logic element. So let me go back in and do my constraint logic. There we go, constraint logic element. And we can just pop that open. And the constraint logic we want to apply is material availability. So there it is, material availability. And this is a two-step process here. First, we need to right-click here and set reference to component material. There we go, bill of materials, component material. And then we need to do the quantity. So here is the bill of materials quantity. Bill of material, let's see, bill of QTY. So there we have that consumption right there. And then I'm going to close that. And then the last thing I need to do is I have to remember to do this is set the reference to that table. So set the reference to bill of materials so that we can see that the green arrow there. So again, two-step process, set the reference there, then opening up the dialog box and setting the particular values. And so now when we go back, we have our constraint logic element defined. So I can go into kit, and then we have this other routing out options, and we have constraint. So let's just grab this guy and then specify that constraint logic. And so now what we're telling it is I want you to apply that constraint here at kit, and what should happen is order one, which requires component D, which we don't have, is going to be stuck, but everything else is going to flow through. So we click run. Now you can see order 2 went through, and once order 2 goes through, 5 is going to 3, and then 4, and then 5, and everything. So here's 1 stuck back here. And so by implementing that constraint logic element at the transfer node, that means that we're not going to block the server if entities behind that the one that requires component D have their component materials, they'll go ahead and flow through. And so to finish the model, what I want to do is I just want to add that same constraint here for a symbol. So other routing out logic. I guess we don't have any materials there. We could do it to be complete, but we won't do it for this one. Go back in and add for the constraint logic element here, constraint logic element 1. So now if we're out of paint for one type of module, then it won't block other orders. And similarly for package, we will add that also. So routing out logic, constraint logic element, constraint logic 1. Okay. So that was some simple testing for our material consumption, but let's go back and add some status plots that can really help. So if we go to kitting, what I want to do is go here and then go to animation and add a status plot. We'll just enlarge that, put it there. I think this should be about 0.7 maybe. Looks reasonable. And we'll start out with, a 2-hour time window. You have to experiment with these values. And what I want to do is component inventories. So we're going to do component inventories. And what we're going to do is we're going to track the components for component A, B, C, and D, the inventories. So we have comp A, quantity in stock. And so this is component A. And let me copy that to the clipboard, add another one for component B. And so this is comp B. And add another one for component C. And that's going to be comp C. And then finally, component D. Oops, I guess I just paste that in and then change that to a D, comp D. So there we go. So now we have our dynamic plot. And so when we run, we should see that material being consumed. So there's the first consumption should have happened there. There's another consumption here. There's consumption. I think I need to make my time window a little bit bigger. Let me go back in here and make this a little bit smaller. Make our time window I don't know, let's make it 12 hours. And now we should be able to watch as order 2, then order 3, then order 4, then order 5 go through. We can now see those components being consumed over time. If I go back in and then set, let that stop, go back into materials and set this assume infinite to D to be true, then I can go back in and immediately I should see, because we know that order 1 consumes D, I should immediately see that go negative. So we go there, and of course that's exactly what we see. Immediately component D is a negative value. And so we should do some additional testing. So ideally what you would do from a testing perspective, I'm going to leave this to you to do on your own, but we should have a similar plot to component inventories here for our paint inventories and a similar plot here for our package inventory so that we can monitor those inventories over time and again do some additional verification. And so lastly in this video, let's go in and add some additional orders. So I'm just going to delete all of these orders that we had for testing, and then I'll just go in and add some that I created in Excel. And so I have these let's not do the due dates. Looks like I have the due dates before the arrival dates. So we'll just skip those for now and paste those in. And then it just uses the default due date. So it doesn't really matter what those due dates are. We just wanted to paste in the order so that we could see, it's kind of a few more orders than we saw that we created manually. So I think I have all of these components still set to infinite availability. So we're going to see these be negative. And so if we run, let's see here, let's just run our create plan. We see a whole bunch of stuff happening here, all of our orders happening. We see some things being constrained, the hatch lines, go down to our, have a look at our entities. And so again, I'm pretty, at this point, satisfied. If I was really doing this model, I would do a lot more testing. I would go in and look, and I would go in and manipulate my data. So go in, for example, and say, let's manipulate some of my materials. Let's get rid of the assume infinite and set the value so that I could actually watch things happening and make sure that it's performing as expected. And that's an important thing to do because as you add more and more logic, it gets harder and harder to find errors that were introduced way earlier in the process. So that concludes this video. And once again, you should experiment with the model and so on. And then so for the assignment for case study 3, you're going to replicate this model and then do some additional testing based on some scenarios that we provide.